Hello there, people. Right, so I thought I would have a go at expanding on this feature of our evolution where we are supposed to be able to deal with all the toxins, natural toxins, highly reactive substances, and so on that this Earth throws at us. So, in other words, oxygen, UV light, glucose, sugars, simple sugars, free radicals, stuff that's out there all the time, and but our body has designed and evolved to be able to deal with these all day long, every day. The problem is glucose. So I made a couple of really crude slides, which should hopefully make this a bit more obvious and clear. So this is very simplified and only follows one pathway down on the left. There's many, but you should get the idea. So we evolved in an environment of oxygen, UV light, glucose, natural free radicals, all this stuff that's highly reactive and always present. But we have autophagy and enzymes deal with these daily. So the green bit is up there. So autophagy will deal with free radicals, damage from free radicals, and damage from UV light. You'll repair from them. Enzymes will detox the byproducts, so like from glycation of sugars, or the oxidation stuff from oxygen. So it already knows and already can deal with it. The problem is when any of these environmental factors reaches toxic levels. If that's all working properly, it shouldn't. And this is where glucose come in, because with glucose, there are further knock-on effects. Well, it'll shut down autophagy and stop these enzymes from working. Cue this. This is what happens when glucose gets involved. So the way this kind of works is, so oxygen has two unpaired electrons. That makes it highly reactive and ready to bind to new molecules. Great when for respiration, but not so great anywhere else. So when O2 gets where unwanted, any contacting molecule will bind and fold into a new shape. And for a molecular machine like a protein, where shape is everything, this will make it non-functional. If you've heard of cystic fibrosis, that's a classic example. It's a genetic disease where people aren't making a protein the right shape, and it's just not the right shape, and it causes that genetic disease. That's how important shape to a protein is. So it's critical that this damage is prevented. So enzymes either intercept the route to oxygen becoming what we call a reactive oxygen species, where it's becoming a free radical, or cleaned up after damage, which is what autophagy does. So that's all good. But the problem is when you add glucose. So glucose toxicity is damaging by itself, but it also interferes with the O2 oxygen oxidation cleanup process. And that happens ideally before the oxygen gets to become a highly reactive oxygen species, ROS. That's what we call it. So we've got ROS down there, just for short. So that's two of the four main environmental factors excess glucose affects. It's a double whammy. That's the problem. Why? Well, because glucose causes glycation, where this sticky sugar molecule attaches to other proteins, enzymes, and deforms them, just like oxidation will. And that makes them non-functional. So the more glucose in your system, the more glycation you get, and the more enzymatic damage you get. And this is where you find it's a positive feedback loop as well as a double whammy. So if you look at this one pathway, where we use the catalase example. So what makes glucose toxicity a double whammy damage is when it glycates and deforms enzymes like catalase. Catalase is what's cleaning up hydrogen peroxide in this particular case, turn it into oxygen and water. If that doesn't happen, then it carries on being reactive and can end up being hydroxyl, which is a highly, highly reactive free radical. So you damage that, you damage all this critical cleanup function, and it fails. So how is that so bad? Well, because oxygen respiration generates this hydrogen peroxide, amongst many other things. Catalase, amongst many other enzymes, breaks that down before it can become this hydroxyl free radical, which is extremely reactive. But catalase, primarily in the pancreas, is not very abundant, so it's easily overloaded. And if it's deformed by glucose glycation, well, whatever's there, then suddenly this whole process breaks down, and that leads to oxidative stress in the beta cells in the pancreas, and that will lead to cell damage and death. And of course, this damage then affects insulin production, because that's partly what beta cells are there for, making the glucose cleanup process even less effective because you're not producing enough insulin to deal with the glucose. So it's a double whammy. So, and of course, what is beta cell damage? It's type 2 diabetes. So not only all this, but the high levels of glucose energy will, when you got that spare energy, it will slow or stall autophagy, which is the current understanding. So you need the less glucose for autophagy to work as well. So it's going to stop your enzymes from working, and it's going to stop autophagy. So it's going to stop the thing that's trying to prevent damage, and stop the thing that's trying to clean up damage, just by having too much glucose in your blood. It's a double whammy, and it's a positive feedback loop, which is why your body starts falling apart. So anyway, if in doubt, go ketogenic. Our bodies can't deal with you eating excess sugar because it interferes with the natural cleanup process and the damage prevention processes. It's causing catastrophic problems that you have no idea are happening until you start becoming seriously ill. And this is one of the reasons why carnivore is so effective to your health, because this happens and it starts, and everything works properly. This never gets to that state because you never have enough glucose to start getting all these knock-on effects.